This is filling and wrapping investigation 4, the ACE homework from 4.5. There are a lot of confusions on this, so I want to make sure that we have them all taken care of. So if I have a square prism and a square pyramid, they have sides of 3 inches and a volume of 225. I know that the base of both of those is 3 by 3. This makes a pyramid, and then I have another one that makes a rectangle. Oh, there. That is also 3 by 3. So I'm trying to find the height and the height. Now I know that volume of a rectangle is length times width times height. And the length equals 3, the width equals 3. So I know the volume of the rectangle is equal to 9h. Tells me this is 225. Using train tracks, I'm going to divide by 9, and I get my height to equal 25 inches. When I'm talking about the pyramid, I know that my equation is 1/3 length times width times height. So I know that 225 is equal to 1/3 times 3 times 3 times h. So if I divide by 1/3 times 3 times 3, divide by 1/3 times 3 times 3, then I get h equals 25 inches. If I look at 19, it says sketch a cylinder. I'm going to trust that you can sketch a cylinder with a ball that is touching all of the sides and the top and bottom. It has a diameter of 18 centimeters, which means it also has a height of 18 centimeters. So if it's asking for the volume of the cylinder, I know that to find volume of the cylinder, I'm going to go pi r squared times the height. My radius is going to be half of 18, so the volume is equal to pi times 9 squared times that height of 18. I know that the volume is equal to pi times 81 times 18, and you can do the rest of the calculations from there. For the volume of the ball, I know the equation is 4/3 pi r cubed. So I'm going to go ahead and go 4/3 pi. My radius again is 9 cubed. Make sure that I cube this before doing anything else, and I can solve it from there. Find the volume of the spheres. Again, the equation is 4/3 pi r cubed. I'm given a radius here. I simply substitute that in. Over here, I'm given a diameter. I know that there are 2 radiuses in a diameter. My radius is 7.5 centimeters, and I substitute that into here. For my next one, I see that Waterton has 3 storage units in different shapes. Five minutes? You can get something down. Thank you. Yeah, thank you. So I've got a cylinder, a cone, and a sphere. Each has a radius of 20 feet and a height of 40 feet. Sketch each of them. I'm going to trust you can sketch them. Estimate which one will hold the most water, which one will hold the least. I have to think to myself, well, I know that if I were to put the sphere inside the cylinder, then I would have excess space, so the cylinder would be greater than the sphere. And I know that a cone is 1/3 of a cylinder. So I'm going to estimate that the largest is going to be the cylinder, then the sphere, and then the cone. To find, so that was for B. To find the volumes, I know that volume of a cone is 1/3 pi r squared times height. The volume of a cylinder is pi r squared times the height, and the volume of a sphere is 4/3 pi r cubed. I'm going to now substitute the radius in here, here, and here, and I'm going to substitute this height in here and here, and solve for C. To find the radius of a sphere with a volume of 250 inches, we again need to start with the volume of a sphere, and that is pi r cubed. It gives me the volume, so I'm going to substitute that in here. I know that is pi r cubed. I'm going to do some train tracks. I'm going to divide by pi and divide by pi. Now I've got 250 divided by 3.14. So I have 79.6 is equal to radius cubed. Now, in order to find out or how to undo this, I take the cube root, which means that I need to take the cube root of this. To leave it like this, well, to leave it like this is sufficient. If you actually calculate this to find what that radius is, that is fine as well. Oh, excuse me, I forgot the 4/3. So, sorry, let me back that up. To undo times 4/3, I'm going to multiply by the reciprocal. That cancels that out. Multiply by the reciprocal. I now see that I have 750/4 is equal to pi r cubed. I know that 750/4 is 187.5 is equal to pi r cubed divided by pi via train tracks. So I now have 187.5 divided by pi is equal to r cubed. Take the cube root, take the cube root, and so I see that the radius is equal to the cube root of 187.5 divided by pi. If a scoop of ice cream is a sphere with a radius of 1 inch, how many scoops can be packed on this cone at the right? So I need to find the volume of the sphere. And so I know that is 4/3 pi r cubed. Radius of 1, really easy, 1 cubed. So give me 1, so the volume is equal to 4/3 pi. I need to now find the volume of the cone. So I know the volume is equal to 1/3 pi r squared. That also has a radius of 1. So I know the volume is equal to 1/3 pi. 1 squared is 1. And so I see how many scoops can be packed into the cone at the right. Oh, is pi r squared times the height. So I have 1/3 times 5. So that gives me 5/3 pi. Now I need to see how many times can 5/3 go into 4/3. And I see that I would go 5/3 divided by 4/3, so 5/3 divided by 4/3 using the reciprocal method is 5/3 times 3/4. those cancel out, and I get 5/4, or 1 1/4 times does it go into the cone. On 28, the float is made of a pouring root beer with 3 scoops of ice cream until the glass is filled 1/2 inch from the top. A glass is in the shape of a cylinder with a radius of 1 1/4 inches and a height of 8.5 inches. When in doubt, I'm going to go ahead and draw a picture. And so I have a radius of 1 1/4 and a height of 8 1/2. I also have my sphere, which has a radius of 1 1/4. There'll be more ice cream or more root beer in the float. Because I have 3 scoops of ice cream, right, I'm going to find the volume of the sphere, which is 4/3 pi r cubed. But I'm going to multiply all of this by 3 because I have 3 scoops of ice cream. I'm then going to find the volume of my cylinder, which is pi r squared times the height. And I'm going to compare and I'm actually going to take off 1/2 inch from the height because the glass says that it stops 1/2 inch tall. So for my height, I'm only going to have an 8-inch height. And I'm going to calculate now the volume of the cylinder. And I'm going to calculate the volume of the cylinder, total. And then I'm going to calculate the volume of the sphere. And I'm going to see the difference between the cylinder and the sphere will give me the volume of the root beer. And I'm going to compare the volume of the sphere and the volume of the root beer. I skipped 45 and went to 50. So to solve this, I really have 3 shapes here. I have half of a sphere, I have a cylinder, and I have a cone. I'm going to, using these measurements, I'm going to find the volume of that. Be careful in finding the volume of the sphere. It's going to be half of 4/3 pi r cubed. This cylinder is normal as we've done it, and the cone is normal as we've done it. For B, it says if 1 inch represents 20 feet, because all of these are in inches, I'm going to find the total volume that I have, and I'm going to create a proportion. I'm going to say that 1 inch is equal to 20 feet. And I'm going to know that that if I have